Hello, welcome to another Random Code stream. This is Random.Code 2025, part 6. Let me get my music going and we can begin. All right, so the last stream I left off on this problem. I thought, oh, it's the part 1 of a day, so it can't be that hard, right? Those are usually a little easier. And that one threw me for a loop, to say the least. Let me make sure. Is my music actually? Yeah, it is playing. Yeah, it's kicking in. Okay. Oh, I also should get my standard coffee. Gotta have coffee. Okay. So I wasn't getting the right answer. And I have to admit, I did take a look at this last night, and I think I figured out what the issue is. Is that when you look at this one, how did I come to the conclusion that I did? I think so closest together are these two. So you connect those two together. And now the next two are closest together are these two. Okay. And you put this one in the circuit for these two. So that gives you 3. Now this one, neither one of these are in a previous circuit. So those are by themselves. This one, these two, are in the first one. So nothing happens. I think what I wasn't realizing, and it took me a while to see this, is you need to I just realized something too. No, you wouldn't need to do that. Because it would just be... three largest. Yeah. Okay. So you don't do anything. I think what I wasn't realizing is if you found a circuit, if you found a pair where each node or position or box, whatever you want to call it, is in a different existing circuit, you have to combine those two circuits together. So I put some notes together to explain this. So so let's say we have a circuit that has, and I'm not labeling by their position, I'm just saying these are, like, they're by their points. I'm just saying here's like box 2, box 4, box 7. Okay. And I have a circuit that has 3 and I have a circuit that has 2. So there's 4 possible results. So let's say we got this. That means neither one of them is in an existing circuit, so you just make a new one. This case, so one is in a circuit, the other one isn't. 2 is in the first circuit, 5 is not in any of them. So then you would put it in here. 2 and 3, the 2 is in the first one, the 3 is in the second one, so combine those two together. And then 2 and 7, they are already in this circuit. And so you just do nothing. Yeah. So I think this actually is going to simplify the logic just a little bit, I think. We'll see. So I think that should hopefully get us to what the problem is actually trying to state. So what we want to do is these are our networks, okay? That is our smallest pair. And then we're going to remove it. So now what we want to do is say we want to find a circuit, and I should explain this. That like, well, how'd you get 2 and 7 if you could have had 2 and 4 and 4 and 7? Then you found that 2 and 7 is like the next choice. So they're already in there, so you're good. Okay. So what you want to do is, let's say P0 existing network. So we want to go through networks. And the way that we're doing this is we should have a singular default. There's no way that you would ever get network contains smallest pair value P0. Key P0. The way we're going to do this is you're either going to find one or you're going to find none. And then we do the same thing for P1. We say find it for P1. Now we've got some cases to look through. Okay. God, I need that coffee. I need that sweet, sweet coffee. More like bitter, dark coffee, but you know. So let's say that if P0 existing work is null and P1 existing work is null, then what we do, oops, I can't, there we go. We can now say networks.add a new where what we want to put in are the points. So smallest pair key, P0, P1. Okay, so that's the first case. Now let's say, whoops, that's not what I wanted to do. Else if P0 existing network is not null, if we got in here, that means they were both null. If not, that means either neither of them are null, or one of them might be null. So we could say if that's null, that means the other one is not null, which means it wasn't a circuit. So in that case, we want to say the P1 existing network, we want to add the smallest pair key P0. And then we have to do that. And then we have, well, we don't have to do that, but There we go. So if P0, P1 exists, we know that. And so we add 0 to it, and then we do the reverse. Else if P1, then we go to P0 and we put in P1. So that takes care now of these two conditions. Now we want to say else if P0 existing network is equal to that. We do nothing. Else well, we could do the not equals. So they're not the same. Okay. Okay. So the case of where they're in two different circuits, we want to combine, we want to say like P, we could say P, add append. I really wish hash sets had a way to say like add a range. I don't know why it doesn't. I mean, I kind of get, but it would be really helpful. It would definitely be helpful in a case like this. I want to put that in as a side note. We could decide to make these not hash sets and just make them lists, because the way we're doing this is that you're never going to have, and so then these are like this, and then we can say add range. P0 existing, we want to add P1 existing network. Okay. Now we want to remove networks, remove P1. And it wouldn't matter which one we're doing, because we're just combining both into one, and it doesn't matter which one it is. Okay, so let's go through this logic again. We see if the first box is in any of the networks. And we do the same for 1. If they're both null, that means they don't exist anywhere. So make a new network. Okay. Now, if 0 is null, it means it doesn't exist. So put it in P1s. If P1s exist, put it in P0s. If P1 is null, yeah. If they don't equal, that means they're in two different networks. Combine them together and remove the other one. Otherwise, they're equal. They're already in the same network. They're in the same network. Don't do anything. What does that do for our answer? It passes. Okay, well, there is no run day 8. So we want to say 8, 8, doesn't that have a part 1? Oh, we got to say how many, 1,000. Because the problem says find the 1,000 pairs which are closest together. took a little bit, but we got a number. Is it the right one? Another star. Woot. Firecracker. All right. I can't imagine how part 2 is going to go. Before I do that, let's commit. And then I want to just put in some tracing. I want to see where it took so long. So, part 1 of day 8 is done. So let's come back here and let's just put in, I don't think it's the parsing. We could say console, right, line, parsing, complete. Thanks. Thanks, hello. Appreciate it. Distances, complete, so we calculated the distances. And then networks complete. I think it's this. I think it's this part that's the slowest. I can't imagine it being this. But let's see. Parsing distances. Yeah, those are really quick. It's the getting through all those. But that second time I ran it, it wasn't too bad. A couple seconds. And there's probably ways I can improve that. Let's take all that out, because I don't want printfs and garbage. Okay. I just had a thought. What do I want to... I just had a thought rip through my head and then I forgot it. Oh well. Oh, if we did... That's right. We did release build. You know, release builds are not necessarily faster, but... If I ran it again... It takes about 5 seconds, I think, roughly, if I'm just ticking off in my head what it is. So either way, it's good. So I got the feeling, though, the second part is going to be worse. The L's were right. Excuse me. The L's were right. They definitely don't have enough extension cables. You'll need to keep connecting junction boxes together until they're all in one large circuit. Oh, great. Continuing the above example, the first connection which causes all of the junction boxes to form a single circuit is between the junction boxes at that and that. So I think in this case, what we do is the same thing, except once we get a circuit that has 1,000? Because there's 1,000 in there. Once we finally get a circuit with 1,000 in there, and we know again because that will be a unique set, until they're all in the same circuit. What do you get if you multiply together the x-coordinates of the last two junction boxes you need to connect? Whew. Well, the simple way is to brute force it. And I don't know how else you would do it off the top of my head. So in this case, we basically just say go until you have a network that has the same amount of positions. And then you take that network and you find the last two nodes and you multiply their x values together. Simple, right? It's so simple. And if I look at, yeah, so the longest, we got to be careful about overflows. If we did 99999 times. And a long is like what, 2 to the 63 minus 1 or something like that. Oh yeah, easily. They'll easily hold it. Just making sure. Okay. So it's probably going to take a while to do. Not to code it, but to let it run. And again, there's probably some optimization that, if I think about it, will kick in. Okay, so we parse, we get the pairs, same thing. Now we want to say, while there isn't any networks network count is equal to the number of positions. And actually, to be probably a little bit careful here, say greater than or equal, I guess, just to be. So as long as we have 20 positions, we go through the networks. Maybe the first one is 5. Maybe the first one, and then we have 6. Well, neither one of those are going to do. So get the next smallest pair, figure out how to do your network, and come together. So then the result here is return. Var largest network is equal to networks we want to say we can do this order by descending, take the first one. And then we return largest network. That's at largest network count length. Count? What is this? Single. Yeah, there we go. Count minus 2 times 1. Oh, x. X. Oh, and then we want to return a long. And it's going to give me the index operator. There. Okay. So to go through this again, we're basically are now trying to find when we finally hit the condition where we have a network that's greater than or equal to the positions we have. And the way that this code works is you're either going to make a new network, which would be 2, you're going to add one or combine two together. But they should have been unique anyway. So you should have had at most, you shouldn't be going over, but this is just a catch. Well, we'll see if this actually works. And I bet this is going to take quite a long time to run, even for a small set like this. We no longer put this number in. I said the number that comes up is this. All right, let's get some coffee. Let that run. And it failed right away. Yippee! Well, that actually ran, and it ran quite quickly, but it did not give us the right answer. We have one network that has 20 in there. How? What did I do wrong? Okay, I'm going to debug this quick. Because that came back so fast. I'm like, that can't be right. Okay, so we go through. We get the smallest pair. It should be in nothing, so we add a new network together. Okay, and then we remove that one, because now we want to get a different one. Okay, so we add in this, so we have 3, which is fine. That works. So now we make a new network. We have what now? So we are getting... We are getting bigger networks, and it seems like it is working. But I think there's a slight problem in like combining 2 together. The first connection, which causes all the junction boxes to form a single circuit, is between the junction boxes So let me do this. I think what I need to do is capture the last two junction boxes. So we want to pair, point pair, last pair. And this could be null. Yes, we're not using it yet. So what we want to do is we want to say last pair is equal to smallest pair, the key. And so what we want to do is, we don't need to do this. We just need to say return last pair P0x times last pair P1 of x. Whoops. Now what? Ugh. Gross. Fine. Just say default. There. Now what do we get for the answer? Passes. Okay, so that was the thing that I missed, is that we have to keep track of the last one, and once we finally made a network that's as long as we want it to be, then that is the X's that we need to return. So if we go to our program here, and we say part 2, so we don't need to pass in this number anymore. And we let that run. Part 2 might take a while. And again, this is brute forcing it, so there may be a much more elegant way of doing this. Though I have no idea what it is. Oh, well, we got a number. I mean, it didn't take that long. It definitely took some time. And we know this is... Whoops, that's correct. Wow, we are moving and grooving this morning. That's awesome. We got 2 stars. Part 2 of day 8 is done. Yippee! All right. That is good progress, and that means more coffee. That part 2 was actually much simpler to do than what I thought it was going to be. I just had to capture the last value that you put in. There is probably a more elegant way of doing this. I'm sure. So this is one that I would want to go back on and say, what am I missing to make this quicker? It would be interesting to watch this as it's pairing up and down and getting, more in and seeing how it combines the two together to get to that answer. But, it is what it is. Now, we're still missing 7. We will come back to that eventually, but not today, not this morning. We're going to Move on to 9, movie theater. Again, I think I have a solution for part 2 of day 7. I just want to keep moving ahead, and then I'll come back to it later. I've got notes on, I think I got notes on how I want to do it. If I look at my notes. Yeah, keep track of the path. You don't have to copy. You just keep track of the path, and then you go up and down, and hopefully that works. All right, so movie theater. You slide down the fire pole in the corner of the playground and land in the North Pole base movie theater. The movie theater has a big tile floor with an interesting pattern. Elves here are redecorating the theater by switching out some of the square tiles in the big grid they form. Some of the tiles are red. The elves would like to find the largest rectangle that uses red tiles for 2 of its opposite corners. They even have a list of where the red tiles are located in the grid, your puzzle input. Largest rectangle that uses red tiles for 2 of its opposite corners. Some of the square tiles in the big grid. For example, showing the red tiles as this and the other tiles as that, the above arrangement of red tiles would look like this. You can choose to add any 2 red tiles as the opposite corners of your rectangle. Your goal is to find the largest rectangle possible. Oh, I see what it's saying. Okay. So, I get what it's saying. You basically have to figure out the area, which is the length times the width. Of all of them and say which one is the largest one. Now, you can brute force this again and say, you know, start with this one and then go through all the tiles and find out what their areas are. And then go through this one and go like here, because if you did this one and this one, it's basically going to make, and it'll be hard to show this, but like this line, and this line. And then you do this one and you compare all of them and you know, you move on. And I get what it's saying is because the largest one you can make is between this one and this one. So I can brute force this and that'll give me an answer. But the problem is that I think well, we can kind of do what we did in the last one, right? How many points could there possibly be? Wait, I should have... Back up. 8. 9. Grab. There. 496, and all these are just area calculations. And you just simply find the largest area, right? And so the area between 2 and 5 and 11, 1 is the length, which is 11 minus 2, 9 plus 1 is 10. 5 minus 1 is 4 plus 1 is 5. So 10 times 5 is 50. Those calculations are going to be super fast. And again, we'll use longs for these. So I think I got a solution in my head. It's very similar to the previous problem. I think. Somewhat similar. Sort of similar. So, again, a mutable array is string. First we want to do is parse them out, and we're going to have a point, except it's just going to be x and y, and we don't need pairs. Because we're not keeping track of, we're just keeping track of the longest length, okay? So we can get rid of this parse. We don't need distance pairs. We need var, and we want this to be along as well. These can technically be u-longs, but whatever. Var maximum area is equal to 0. L. Okay, so we go through all the positions. We're going to offset by 1, except we're not going to do that calculation. We can get rid of all this. We can actually get rid of a lot here. Okay, so then we want to return maximum area. So we get the I position and the J position. And the area between these two would be, the number of tiles, however you want to think about it, is long.abs of I position X minus J position X times long of abs of I position Y minus J position Y. Now, is that really what we want? Oh, no, +1. I forgot about that. That would have been deadly. I read some stupid comment yesterday. Somebody posted, I don't know, it was on Blue Sky, because I'm not on Twitter. Twitter sucks. But, yeah, and quite frankly, social media in general pretty much, a lot of the internet just sucks these days. It's old man ranting. But the comment was from somebody who's saying that in 2026 with AI, Gen AI development and all this stuff that, developers have to keep moving faster, and we can't keep like trying to get the software to be perfect. We have to keep beating the competition, and so developers are going to have to get used to not necessarily having software that's absolutely perfect. And I read that, I'm like, that is the dumbest thing I've ever read in my life. Yeah, like you want your calculations for your bank when you're either withdrawing or getting cash. Oh, if we're off by $1 or 20 or 100, it doesn't matter. Oh, we did this interest calculation rate wrong. That doesn't matter. Oh, we screwed up on how much medication the label says you should take per day. Pfft, it's off by 1 pill. What could that possibly do? It's the dumbest thing I've ever read in my life. So, yeah. Just me? Don't know by what you mean by that. Sorry. Scratch. I think that's what your name is. Again, LLMs can definitely help out and make development go faster, but it doesn't mean it's all going to be correct. You still need to do what you can to make sure that it's doing, and being precise does matter. It absolutely matters. And if you're saying, well, in business calculations, it doesn't matter, that's absolute bullcrap. Yeah, I don't know, Guy, if you missed my rant on, I read yesterday somebody saying, in 2026, developers have to, keep moving faster with AI, and so they have to stop worrying about having their software be perfect and precise. They got to keep, pushing out the stuff as fast as they possibly can. I'm like, that's just a comment that's made exactly so that it gets views and it gets people like me riled up. Day 9, yeah, I still haven't done part 2 of day 7, but I got a plan for that. I'm just going to come back to that later. So day 8 I worked on yesterday. Didn't get it right, but then I thought about it last night, and then this morning I fixed it, and part 2 was actually not that bad. So now we're working on day 9. Do they work for Boeing by chance? Yeah, exactly. That's an astute observation right there. All right, so we get the area here. Now, if the area is greater than the maximum area that we found, maximum area equals area, and we return that. A user form. I think this is it. Now, this is also going to, as we found last time, we could do the distance calculation between 2 points and get like all of them rather quickly. So this feels like I'm missing something. Let's see if we get the initial small data set correct or not. 9. Need to make this 9. 9. Okay, we'll wait on part 2 in just a moment. Part 9, come on. And we don't need to pass that in. So they're saying for this data set, it's going to be 50. We got to change it so that we're actually getting the right data set. Okay, well, that passed. Go big or go home, right? Let's get the 9 in there. Nine. Just thought of that part in that Glorious Bastards. 9999. It was funny. I was watching, I don't know where or when that was I was either watching Glorious Bastards or I had that scene. I was just watching random YouTube videos one night, and this is a couple years ago, and that scene comes up where the guy who's playing Hitler says that. And I think both my kids were in the room, or one of them was, and they went, "That's where that meme comes from." They had no idea. They had heard it or, whatever, but they had never seen where it actually was from. So all right, day 9. Well, that's a number. That feels awfully large for some reason. I don't know why. Let's see. Well, we are on a roll this morning. Okay, the second part's going to be awfully hard. That was part 1 of day 9 is done. That just felt a little bit too dopamine plus. Yes, exactly. Should that have been a prefix operation or a postfix operation? All right, how is the second part going to kick? The elves just remembered they can only switch out tiles that are red or green. So your rectangle can only include red or green tiles. In your list, every red tile is connected to the red tile, before and after it by a straight line of green tiles. The list wraps, so the first red tile is also connected to the last red tile. Tiles that are adjacent in your list will always be in either the same row or the same column. Using the same examples before, the tiles marked X would be green. In addition, all the tiles inside this loop of red and green are also green. So in this example, these are the green tiles. Remaining tiles are never red nor green. The rectangle you choose must still have red tiles in the opposite corners. But any other tiles it includes must now be red or green. This significantly limits your options. For example, you could make a rectangle out of red and green tiles with an area of 15 between red 7.3 and 11.1, or you can make a thin rectangle with an area of 3 between 9 and 7. The largest rectangle you can make in this example using only red and green tiles is an area of 24. Yeah. So he's saying is you basically connect all of these to come up with your boundary, and then you have to find a rectangle within that, because before you weren't limited by that. You could just say any two that could give you the largest area, which ended up being this one and this one. God, I hate that when you just highlight something in Edge, it just, oh, let me do a search for you. Now it's saying, what is the largest area of any rectangle you can make using only red and green tiles? I think if I looked at that, yeah, it basically grabbed this one and this one because, see, mother, hate it when it does that. I should turn that off. That is still within the bounding of this. So you could still do the logic you did before, but you can only do it for you can only do it for the area that exists within this binding area. And again, if you look at the data here, I can't visualize that. But I'm guessing it's some really weird snaking thing back and forth, to go, well, are all of these in that area? That's definitely a harder problem. I'm not saying it's impossible, because obviously there's an answer to it, but it's not as simple. You have to know which points exist, and then you also have that are valid, and then you also have to know yeah, I think I might skip to 10 again on this one right away, because I want to just keep making progress in stars. You're going to end up, I get the problem that you have to solve. You're going to end up having some complex shape that all connects around, but then you have to find within the points that you have, those two connections, if all of the points that would make up that area exists within the larger area, then that can be considered as part of the maximum area value. So you just have to figure out then what this shape is, and when you calculate between two of the points, does that exist within that all of it, does it exist within the bounding area? Binding, bounding, whatever you want to call it, area. And that one, that's the hard problem. That's the hard part. Conceptually, I get the idea. It's just trying to figure out of a way to do that is not as easy. At least I can't think of a way off the top of my head, because I don't have data structures and algorithms that would tell me, does this area exist within this area? That's really what you need to solve, is saying I have a shape that's defined with all these coordinates. Does this shape exist within this shape? Like does this area, does it exist within the whole area of the bounding shape? And if it does, then I can use that area calculation and say, is that the max area? It's just trying to figure that out. Does this shape exist within another shape? So I'm going to skip this for now. I get the general problem. So let me put my notes here. I know it's like, you're cheating. No, not cheating. I'm just day 9, part 2. General problem. Does a shape exist within another shape? Let's move. Factory, just across the hall. And it helps for me sometimes with these harder ones just to sit there and think about it longer. I don't want to necessarily spend time on a stream spending all my time just trying to figure out what the actual answer is. I feel like sometimes it'd be better if I just went off camera and thought about it for a while and then not solve it, but go, hey, I think I've got a solution for it. That's kind of like what I did with this one, hey Leo, and went, I'm not handling cases right. So I wrote down some notes, but it actually didn't implement that until this morning. And then like this one, I have notes to say, I think I know how to solve that. I just got to go back and doing it. So I need to think about that. How do you figure out what that area is? And is that area that you're calculating between 2 points within the larger area? And I just don't know how to do that off the top of my head. How was the Avatar movie? It was exactly what I expected. It... I know I've heard that he wants to make 2 more, and that doing 4 and 5 would be dependent upon like how 2 and 3 did from a financial standpoint. I have the feeling that there will be a 4 and 5 made, and I heard it's going to be until another 3 or 4 years. Like they have to do those 2 together, and they won't be released. The plan would, I've heard, would be until 2028 or 29, then 2030 or something like that. Because I think Cameron also wants to do some other movies. But visually, it was stunning. It's like, I think it looked even better than the second one. It just, it is amazing how well they look. It's just... It's undeniable that Cameron knows how to make a movie that looks good. I will argue that till the cows come home. Him and Ridley Scott, I think both of them can film movies that look just stunning. Story-wise, the first Avatar actually was somewhat interesting. I think part of it was something that we really had never seen 3D done well as that. That was like one of the big things with Avatar, is that it was this, like, yeah, it's 3D, but it was updated with new technology so that it looked much better when you saw it. And the storyline also was generally interesting. Sometimes, like the Rossi or whatever his name is, he's so one-dimensional. He's actually in this movie again, but not very long. And his character is just annoying. Like it's put in there just to be like the typical corporate, sentience be damned, I want my immortal juice type of guy. It's I guess maybe there are people like that out there in the world, but I don't know. It didn't have anything complicated to the character. And I guess you're like, well, a movie like that doesn't. I do think that all three of the movies, I know Cameron wrote them and probably had, help refine the script, but there are just some lines and some things that were just like, this could have been trimmed. This could have been phrased better. This is going to be a spoiler to some degree, but what big deal. The spider character, the guy who hangs out with the Na'vi, he's got the long dreadlocks and stuff. He's brought back to the human base, and he's being experimented on. If you watch the movie, you'll find out why. And his father, Quidditch or whatever his name is, comes in to talk to him because he's now a Na'vi. He's in the Avatar thing, and he basically gives his son his dog tags, and because he does want to have a relationship with his son. So then Spider uses the dog tags to unscrew a vent that's at the bottom of the floor so he can escape. And I just saw that. I'm like, that is the dumbest plot armor I have ever seen in a movie in my entire life. He was in basically a room that had windows on it so that all the scientists could see him when they weren't experimenting on him. And he was on a bed, and he goes and just unscrews a vent and then just runs out of the facility. There is no way that would happen. No way. If he was that important to them, there is absolutely no way that would have been allowed. That was, like, to me, the dumbest thing in the movie that I saw. I don't know why. Maybe there was some very stunning scenes. In fact, when they were fighting within the human facility, that was actually really cool. I thought that was, I really liked seeing that. Stuff like that is just childish writing. I know you need to get him out of the facility, but it just felt like the way you're writing the story is you need him to be in the facility so he can have this conversation with his father, but then you just let him easily escape. I don't know. It just felt stupid. It felt dumb. So, like, somebody asked me what I think of it. I said probably 7 out of 10. Like, I got what I wanted out of it. I saw an absolutely stunning visual spectacle. Of that, I have no doubt. Story-wise, I would actually be really interested to see, because I know Cameron has the rights to this now. He has the rights to the story of a guy from Japan, and there's numerous people like this, but people that actually experienced both the bombings of Hiroshima and Nagasaki. So he was at the first place and then fled to the second city, and then that got nuked. And he survived. I would be really interested to see Cameron do that story and see just how good of a writer he could be with that, or would he just rely upon special? That was one thing too about Oppenheimer that I didn't like, is that Nolan was so committed to, I've got to have everything like in camera real, that the test explosion you see was not computer generated. It was done with all real effects with explosives and stuff. I thought that wasn't, it just didn't look real enough to me. Not that I've ever seen a nuclear explosion in front of me, and I don't ever want to. But I'm sorry, I'm ranting. But that just, I'm like, for Interstellar, you had to use a lot of special effects. You can't just make a black hole, as much as Nolan probably wanted to. But you had to use special effects for that. Why didn't you use them for something like the nuclear explosion? I just feel his commitment to having everything in camera sometimes gets a little ridiculous. So, anyway. So, yeah. overall liked it, got what I wanted out of it, but it was not a movie that's making me sit here and think, about the story, more about like what I thought was wrong. The thing is, with all the Avatar movies, I think the idea and the premise was decent, and I think you could take that and make it into something that would really be a deep story and a very, very interesting story. And I feel like he's just playing the same hits, especially with the first one I thought was a little different. The second and third ones, I'm like, but he's probably like, I'm getting my money back, woohoo. Does Avatar 3 suffer because we have so many other movie TV options? Maybe, possibly. I mean, this is the value to this movie is the visual experience in a theater with 3D. I think if you just saw it without 3D, it would still look amazing, but just the attention to detail that he has with 3D. And you see this too because they showed a trailer. I need to get back to this problem, but they showed a trailer for something I didn't know he was involved with. He worked with Billie, is her name Eilish or something? Shows you how in tune I am with modern artists and singers. But he's a co-director with her tour, and they filmed the tour in 3D, and they showed the trailer for that, and I was like, wow, that actually looked really impressive. That looked really, really good. And I don't give a shit about her music. Not that I think it's bad. It's just don't follow it. I would almost go see that just because of the way it's filmed, and you like see people holding up their phones, and that's all in 3D as it pans around. I'm like, that actually looked really cool. I think that looked really amazing. Does it suffer though? I don't know. It's an interesting question. Anyway, speaking of a question, I got to solve the answer to this one. All right, factory. Just across the hall, you find a large factory. Fortunately, the elves here have plenty of time to decorate. Unfortunately, it's because the factory machines are all offline, and none of the elves can figure out the initialization procedure. The elves do have the manual for the machines, but the section detailing the initialization procedure was eaten by a Shiba Inu. Oh. A hunting dog, a very cute hunting dog. Oh, look at that guy. Oh, he's so cute. Oh, he's so cute. So, I'm not a dog person. I'm definitely a cat person, but those dogs are cute. Okay. All that remains of the manual are some indicator light diagrams, button wiring schematics, and joltage requirements for each machine. For example, that input. The manual describes one machine per line. Each line contains a single indicator light diagram in square brackets, one or more button wiring schematics, and joltage requirements in curly braces. Okay, so to start a machine, its indicator lights must match those shown in the diagram, where that means off and that means on. The machine has the number of indicator lights shown, but its indicator lights are all initially off. So an indicator light diagram like that means that the machine has 4 indicator lights were initially off, and the goal is to simultaneously configure the first light to be off, the second light to be on, the third to be on, and the fourth to be off. Okay. You can toggle the state of the indicator lights by pushing any of the listed buttons. Each button lists which indicator lights it toggles, where 0 means the first light, 1 means the second, and so on. When you push a button, each listed indicator light either turns on if it was off or turns off if it was on. You have to push each button an integer number of times. There's no such thing as half a press, nor can you push a button a negative number of times. So a button wiring schematic like this means that each time you push that button, the first, fourth, and fifth indicator lights would all toggle. If an indicator light was this, pushing it would be that. Because none of the machines are running, the joltage requirements are irrelevant and can be safely ignored. Okay. You can push each button as many times as you like. However, to save on time, you need to determine the fewest total presses. Oh my god. Holy crap. I can always see where this is gonna... Maybe I skipped this one too. I do need to leave in a little bit. My wife and I need to do some shopping. So, yeah. Jeez. There was one problem last year, the day one I saw it. I'm just like, I have no idea. And I did do some research later, and I found out that a lot of people were like, yeah, the first part was just brutally hard. So pushing all the buttons, because none of the machines are running, the voltage requirements are irrelevant, can be safely ignored. You can push each button many times as you want. Fewest total presses required to correctly configure all indicators. Like, few ways to correctly configure the first machine. You could press the first 3 buttons once each, a total of 3 button presses. You could press that once, and that twice, 4. You could press all the buttons except 1, 3 once, and that would get you an answer. However, the fewest button presses required is 2. One way to do this is pressing the last 2 buttons once each. Yeah. The second machine can be configured with as few as 3 button presses. How? How do... Well... Yeah, how? So the first thing you have to do is parse it. And so you got to find where the right brace is. You can assume the left brace is at 0, so you could just span that out and then find out what the desired configuration is. Then you just keep going through and you just keep trying to find left curly braces or left parentheses, and then you find the next right parentheses after that position, and then the content is the button toggles. You could also get the voltages, but like I said, for this one it doesn't matter. It will matter probably for the second one. I think what I could do is start working on the parsing of this. There's probably a way to do this with a regular expression, but I'm just not that brilliant. But I honestly have no idea to find what the minimum of this would be. You know, and if you probably look at the input, it's probably gargantuan. Yeah. Well, I mean, it's not terrible, but like, how many of these do you determine, and what gives you the minimum path between those? Right? I mean, that's just, ugh. Well, like I said, in the interest of time, I don't think I'm going to be able to get around to solving this, but let's at least start it. Right? Let's at least start it. This is 10, right? Yeah, 10. So let's get the input. Okay. And then let's just try to parse this, because the answer is going to be is the sum of the minimums. So that probably could be an int, but we're just going to do it as a long. So this is day 10. Day 10. So the first thing we need to do is parse out the desired state. So let's just say okay, I don't even know what to return right now at this point. We want to, so we need some data type, public record struct configuration. And what the configuration is it's a string of the desired state. That's what's within the brackets. And then a list of, what'd they call them? I know they call them button wiring schematics, but what would I want to call them? A list of ints. Button wiring schematics. Oh, come on. Hey, what doesn't it like about this? Change button. Why? I mean, I get that you don't want lists to be writable, but I could make these an immutable array of immutable arrays. There. You happy now? So the first thing we want to do is get the desired state. So var desired state is equal to, no, we need to, we need to get var manual is a list of, God, machine configuration. Okay, so now we say for each machine and data, sure. The desired state is going to be machine as span. We want to slice it. We want to start at 0. And we want to say the machine index of this. Right? Or not. String. Oh. Shut up, guy. I can already hear it. So this should get us the desired state. Okay. Now what we want to do is keep looking for left parentheses until we don't have any more. And what we want to do is capture this value. Var right bracket index. And the reason we want that is because we want to use that for where do we start next. While Can you... That'd be a fun one to have. Index of all. Like if I have a character, I want to find out where that is in all of the positions. So I don't know if there's a like a link thing to do that. I don't think there is. But that would be really nice to have, because then I can just say, well, if I know there's four left parentheses, there has to be 4 right parentheses that are all after each one. So like I said, like the first index over, then like if I say start at the left one, it would find the first one there, and I could start the second one, find the first one there. And then I wouldn't need to do what I'm about to do. So, again, probably could do this with a regular expression. And that's what probably people will be screaming at if they see this and going, you could just do this with a regular expression. Why are you being a moron? Because that's just me. So we do want var button wiring schematics is equal to a new list of immutable array of int. And then somewhere down here, we're going to say manual.add a new desired state and button wiring schematics to immutable array. And now it's going to tell me how to make this. Oh, that's a read-only string. A new. There. That's easily readable, right? You could just. Of course, now we have to do the logic to find out the last index of. I think I see where you're going with this. Is I could say is find the last index and then just keep moving previous. I think, if that's what you're getting at. I think that might be what you're getting at, but then I have to keep track of it's just the problem in reverse. Now I can say we'll find the last index of that left parentheses where I go through the string up to the point of the previous one. Right? And we know we're, in this case, we know we're always going to have at least one button wiring schematic. One to end. We don't know how many, but we know there's going to be many. So, yeah, we need to do something that says yeah, now we'll get there. I'll fill that in later. Var left or use string contains and said no. Shut up. I know what I'm doing. At least I think I know what I'm doing. If left parentheses index is greater than 0, or greater than or equal to 0, then we know we have one, right? What are you doing? Advent of Code 2025. It's in the description of the stream. Yeah, trying. Eventually, we want to do that. So now we can get the contents of the points. Var buttons is going to be equal to, we can just say substring here. Yes. And then we want to find the machine index of this. Series of coding puzzles. Thanks, Guy. Appreciate you going through that and answering it more than I would. Actually, we got to do this again. If we found it, we're going to want to say it's equal to, well, that's stupid. We want to find that character starting at, we're going to want to grab the index here. Var right parenthesis index is equal to that. And then we put that in here. Except, no. right minus left plus 1. There we go. Rusty Python, I don't think so. So where we want to start now is the right parenthesis plus 1. And then we loop. Well, we'd come up, we'd do the while, and we'd say, if it was minus 1, we're done. So this now gets us the buttons. That should be the inner part. And that can be var button parts is equal to buttons dot split on that. And now what we want to do is var button values is equal to a new list of int. Except we could do this probably simpler. We could say split select value is equal to these were just integers, right? Yeah. Int.parse of the value. Yeah, I know. Culture, info, whatever. So that selects it and that turns it into an integer, and now we can say to immutable array. Right? So it splits it, it selects it, we make it an array, and so now we can take this and we can say button wiring schematics add button parts. And then when we're done with this, we have the desired state, and we have the button wiring schematics, except we want to make that into an immutable array. All right, so if I just write a test real quick, and then I'm going to have to stop. But, and the test is going to fail. I know it will. But I just want to see if the parsing logic actually works. So we want to come into here, and we want to say this example. Okay. They said the answer should be 7, of course. We're not going to get that, but let's see how this all works. Actually, let's just come down to here and see if I really... Okay, yay, woohoo! The input string 3 was not in the correct format. Oh yeah, we want to parse out hold on. Yeah, we're getting the 3, but we're not subtracting off the parentheses. So that's the index. We want to go one past it. And then I think we want to do something like that. I was at 3 and I had 6. I want to get 7. So I think I actually want to say here -1. Yay! So we got button parts. We add them. And now we say we're at 7. Now we're at 11. Okay, well, what do we end up with? Oh, yeah. Oh, woohoo. Length. How did we... Arg. We want to start at the left parentheses index. Okay, so now if I look at what I'm considering my manual to be, I should have 3 lines in there. Desired states are that. We have a button wiring schematic where we have 3, 1 and 3, 2, 2 and 3. Oh, not that. 3, 1 and 3, 2, 2 and 3. Yeah. So you should have 1, 2, 3, 4, 5, 6. Right? We did have 6. And the last one is 0, 1 and 0, 2. Yep, that looks good. And then the second one, what does the last one look like? 1, 2, 3, 4? 1, 2, 3, 4. Okay, I think I finally got it. At least the parsing of it. Or not. Because I'm not getting the desired state right. I'm including... Yeah, I'm still including the... There we go. So, yep, there we go. We just needed to move it over 1 when we're doing the range. Perfect. Okay, so at least we got that. I have no idea how to actually solve the problem. How do you use these inputs to say if I do this, well, that flips 3. You know, and again, if I'm at a state where they're all off, how do I get them all on? Like 3 would turn this one on. That's not what we want. So, yeah, that doesn't work. But I unfortunately can't make any more progress on this because I do have to go. I might start the next stream by just going to 11 and 12 and then coming back and solving what I couldn't do before. And handling it that way. So you don't need the joltages. You probably parse them before end of stream. Well, I can't do that now. So I could do that, but for this first part, you don't need them. So there's no part in parsing them. You know that it's good. There's going to be, and that's easy because you would just take the index of the left curly brace and then find out where the right curly brace is and do the logic before. It's that middle part where you're finding out all of the button presses. That's a little bit harder. So, but we've got that down. So I at least want to say git commit parsing logic for part 1 of day 10 is done. So at least we have that. Okay. But we don't have any more. But again, I do have to finish the stream here. So I want to thank everybody who's been watching. Either if you're watching live or you're watching a VOD in the future, please subscribe to the channel if you haven't done so already. I would really appreciate you doing that. I will probably do another random coding stream tomorrow morning. And I will be doing a Halo Infinite stream this afternoon. So you can watch for that, and also doing some more Halo Infinite streams tomorrow. I still have 1 more week of vacation. Man, the first week just flew by. But I'm going to be doing more next week because, again, I'm still on vacation. My wife and I are going to be going away for a couple days to celebrate New Year's. So I won't be streaming on those days, but rest assured I'm going to be doing more. So have a good night. It's the morning, guy. Where are you? It's still the morning for me, but I will be back this afternoon to do Halo Infinite, and again tomorrow morning I will be doing more of this and more skipping over stuff that I don't understand how it works. So, but for now, I'm going to end this stream. Thank you all for watching. Take care, and I hope to see you in the future.